Hey, Math 30-1s. Today we're going to do our last worksheet video here. From 12 employees, how many ways can you select a group of 8? Now, it says group here, so I'm assuming that this is going to be a combination question. So this is going to be pretty easy. I'm just going to go 12C8. Not bad. Okay. And then it says, how many ways can you assign 6 different jobs? So this would be 12P6, because we talk about jobs. Each job is different, so it matters who you pick first, because they can get the better job, right? So each thing's gonna be a little bit different there. So I'm gonna do the C one first. I'm just gonna plug in my calculator, 12C8, and I'm gonna get 495 for this one. And for the permutation one, I'm just gonna go 12P6. Oh, geez, that's a lot. There are 665,280 different ways to arrange the 6 different jobs between 12 people. Of course, some people are not going to get jobs, but that's fine. How many combinations are there? Combinations. Yep, so maybe I shouldn't cross off the word. That'd be a bad idea. Let's just actually write it. If we're taking 3 of the letters, so like this here would be the same as this question here. Let me just get my book up here. Okay, so there's my letters. It says I'm just taking 3 at a time. Books falling on the ground all over the place here. Right. If I take 3 at a time, it doesn't matter if they're just in your hands. You just grab them, they're in your hands. So that's going to be obviously a nice little combination. We've got 5, C3, but how many 3-letter permutations are there going to be? Now, order matters there, so each spelling might be different for the words. Okay, so these are going to be different numbers because one is going to be 6 times less than the other. So if I did the P first, oops, syntax error, I should probably put an actual number at the end of that. So 5P3 is 60. And I'm going to assume 5C3 is 10. The reason I know that's 10 is because the formula, the C formula has an extra little piece. It's divided by R factorial, because the ordering doesn't matter. Like I take 3 of these things. There's 6 ways to grab 3 books, because I can grab this one first and that one and this one and then et cetera, et cetera. But all 6 of those are just in my hand. So I just have to divide that out. Okay. How many different ways can a coach of a debating team select a team from 7 grade 11 students and 8 grade 12 students if the team has 4 members and only one of whom is grade 11? Okay, so I have 4 members, but only one is grade 11. So that means I'm going to have, in the team, I'm going to have 11C1. Oops, not 11C1. I'm saying 11 because it's a grade 11. But I have 7C1, so this is my grade 11. And then for grade 12, I have 8C3, because the 1 and the 3 would make the team. And this is going to be and. I have 1 grade 11 and I have 3 grade 12s. So this is going to be 7 times, I don't know what 8C3 is. 8C3? Yeah, 56. Okay, so times that by 7. And so I have 392 different ways I can do this. Okay, so this is an only one, so kind of exactly one. But now here I want at least 2 of whom are grade 12. So I'm going to have some situations here. So again, I have 4 members, but I want at least 2 grade 12s. Doesn't mean exactly 2 grade 12s, at least that, right? So I could have 2, 3, or 4 grade 12s. So I have 3 situations. So I could have 2, 3, or 4, right? So these are my grade 12s. But I have ors here, so that's what's happening here. So or. Then I got to fill out the committee. So if I had 2 grade 12s, that means I'm going to have 2 grade 11s. If I had 3, then I would have to have 1. And if I had 4, that means I don't have any grade 11s on my team. Or this is debating club here. Okay. So 8C2 is 28. I'll just put all the numbers here. 8C3, this one we already know what to do. This one's going to be 56 times 7. So I know this one's going to be 392. Okay. This one's going to be 4, or 8C4, sorry, that's going to be 70 times 1. I know there's going to be 1 because there's one way to select nobody. You just don't select them. That's it. So we get 70 for this one, that's for sure. And then 2 or 7, sorry, 7C2. 7C2 is 21. Right, times 28. So we get 588. So I'm going to add all these together because they're or. So I'm going to go this plus that plus that. Yep, cool. So there's 1,050. Now you could have done the other way. You could have found the total number of committees I could possibly make and subtract the ones that don't include the 2 or more. But that would almost be pretty much the exact same math. If you wanted to try that, you could. I'm just going to leave it this way. Bag containing 9 white marbles and 7 green marbles. How many ways can you draw a group of 6 marbles if it has to be exactly 4 greens? So there are 7 greens, and I want exactly 4 of them. I want 6 marbles in total. So this is the green, and this is the white. Okay. How many white ones? We have 9, and I want 2 more. That's exactly. So I want exactly 4. Okay. Ooh, what happened to my 7? It just disappeared on me. There you go. So 7 C4. C4. No. Okay. 35. And then I got 9 C2. So 36 times 35. So there are 1,260 different ways to do it. Like out of pulling them out, I would have 1,260 ways to do that. Cool. Yeah, makes sense. I want at least 4 must be green, at least. Okay, so at least that. Yeah, you have to think of this. I was thinking about this question, like how identical are these green marbles going to be? Now, if you treat the green marbles to be kind of different green marbles, like one's like dragon and one's like the Hydra or something, if they're slightly different inside, then yeah, this is definitely the answer for this one. I'm going to assume that the green marbles are slightly different, the white marbles are slightly different from each other. Okay, at least 4. I should give more space here. Okay, at least 4. That means there's only 3 cases here, right? So you got 4 green, 5 green, and 6 green. Not 7 green because I only want 6 marbles still. And then I have 2 whites, 1 white, and 0 whites. I should have made a most of 4 for this question because it's slightly different than the one previous to it. That one we did already, so that's good. So 7C5 is 21. 21 times 9 is 186. So 9, sorry. Okay. Much smaller number. And this one here is going to be 7. Yeah. 7 times 1. And again, because of the or, I am going to add these together. So I'm going to go the top number plus this one plus the second, and all together I get 1,456. Cool. Yeah. Okay. So 3 rooms in a university residence contains 3 beds, 2 beds, and 5 beds, respectively. How many ways can 10 students be assigned to these rooms? Is that all the? Yeah, sweet. Okay, so this one's a little bit different because they are kind of dependent on each other. And I could show this later on. That doesn't matter how you fill it up. You can fill the 5 first, then the 3, then the 2, or the 3, the 2, and the 5. They'll give you the same solution either way. So let's say I start off with 10 students, and I'm going to fill up. I'm going to fill up from left to right here. So I'm going to fill up the 3-bedroom first. So I'm going to go 10C3. But now, because I've used 3 kids up already, I only have 7 to choose for the next 2 beds. Then I only have 5 to choose for the next 5. So that uses everybody up there. So I can, 5C5 is going to be 1. How many ways can I choose 5 kids? If I have 5 of them already, there's only one way to do that. You just choose them all. So let's go through here. So I get 120 for the first one. 120 ways to select them. 7C2, I think I've done this already. It's 21. And then 5C5 is 1. So 21 times 120 is 2,520. Now, if I just did it from the other way around, so what if I decide, well, I'm going to do the big room first? So I take 10, I'm going to choose 5 of them, and then maybe just to mix it up here. No, I won't even mix it up. I'll just go the other direction here. So what do we have? We choose 5, so 5C2, and then we have 3C3. Okay, so what numbers do I get here? Well, C3C is 1 again, so that's just going to be 1. Okay, 5, oh, that's 10 right there, so 5C2, and then 10C5. Oh, it's 252, which makes sense. 252 times 10 is 2,520. So it works both ways, right? I'm not going to add those together. I'm just going to mention that, yeah, it doesn't matter how you fill the rooms up. You get the same solution both ways. A roster of a hockey team consists of 10 forwards, 5 defenders, and 2 goalies. How many different teams can you select if you must select 3 forwards? Okay, so I have 10 forwards to choose from, and I want to pick 3 of them. And my team's got to consist of 2 defenders. I have 5. I'm going to pick 2 of them. And I'm going to have 1 goalie, so 2. Okay. So the 2C1 I know is 2. Okay. 10C3, which we already did up there as well. That's nice, 120. Oh, 5C2 we did as well, so it's 10. All these numbers we've done before. That's fine. That's just fine and dandy. Okay, so 2 times 120 times 10. So there are 2,400 different teams we can make this way. Cool. There we go. All right, I'll see you in the next video.